there's a trust problem in the cloud.
National level or cross-national threats, the volume of breaches.
Treating data and AI models as critical infrastructure, on a par with energy and defense. The rate of prescriptions now in Germany, there is over 2 million a day from a digital
And
perspective.
it's all going through a confidential computing.
It's all based on Intel SGX, the quiet revolution. People are turning on confidential VMs everywhere. Social media companies and advertising, cookie deprecation. There isn't an industry that isn't utilizing confidential computing at this point in time.
Hi, Paul. So, welcome to Confidentially Yours. I'm very pleased to have you on. We've known each other for quite a while, I guess. We both, you are at Intel. I've worked there in the past. But could you, not everyone knows as much about you as I do, and I'm sure there's bits I don't know. Please just tell us a bit about what you do at Intel and how you got there. What was your journey to where you are in Intel? I'd love to hear about it.
Okay, how long have we got on this podcast? So I'll try to wrap it up in a few minutes.
I'll stop you when it gets boring, Paul. You know me.
Yeah. I think, yes, we have known each other for a good while, Mike, and good to see you. And thanks a million for having me on as a guest. It's a great honor. So I'm Paul O'Neill. I work at Intel, and I'm part of our confidential computing enabling group at Intel. And really what that means is we stand between what we're developing and what we're pushing to the market, right? So we're bringing feedback back into the business, and we're pushing technology out, and we're evangelizing a lot as well, right? It's a great job for many reasons, but I think one of the best parts of my job is that I get to look out and in at the same time, right? And that allows me to work with big ecosystem partners, the cloud providers, but also those who are building interesting technologies on top of what we're pushing out, like Super Protocol, and as you and I have done in the past in other companies, right? And I think that's always been, for me, one of the most interesting parts of confidential computing is to see this thing grow from, ecosystems to big players, etc. So that's kind of what I'm doing at Intel at the moment, and plan to continue to do, because we have, in the confidential computing world, as you know, we are not quite there yet. We have a lot of work to do, and we have a heavily reliance on our ecosystem partners to deliver all of the things that we want to deliver here at Intel.
Yeah, I think that's always the case for any chip technology, but certainly where it's one which requires integration at lots of different layers and levels, such as confidential computing. And we don't want to go into the technical bits of that particularly, but it is a chip-based technology which does require a variety of different players in the ecosystem to be turning it on, to be integrating it, to be putting it into their various bits and pieces. So how did you get? Are you a techie? Do you describe yourself as a techie, or are you have you managed to avoid that tag, or what's your backstory, if you're happy to tell us?
Somebody asked me this recently, are you a techie? I have to think about it. I think the answer is I kind of used to be. My own team laugh at my technical capabilities now, right? It's a constant mockery. When I say something super technical, they look at me as if to say, how do you know that, right? So, because I just read it off ChatGPT 2 minutes ago or something like that, right?
Yeah.
So my background is I'm actually coming up to 12 years at Intel, and it's probably the longest I've ever been anywhere, right? But, I think I was an executive in a company acquired by Intel 12 years ago, and I came from literally an entire career around startups, right? And now the startup space, right? It's a lot different than working in the corporate space.
It really
But it
is.
gives you the ability to do dynamic thinking and think on your feet and be flexible about different things. And I think coming into Intel, as I said, I don't think I'd ever worked in a company more than 200 people. And then all of a sudden, I'm in a company, 100,000 people. And that took a little bit of time to adjust to, right? But all of my background is software, right? I didn't know what a silicon wafer was up to 12 years ago. Never knew, even though here in Ireland, I'm based in Ireland. Intel is one of the biggest employers and one of the biggest brands here in the country from an employment perspective. But I came into Intel and worked a bit in the cloud space, which is where my expertise was. And then I started poking around a bit in this big company when I sort of settled down and started to figure out, wow, there's an ecosystem of itself in this big, huge company. You know this, right? And I found several other things that were going on. And there was this thing called blockchain, which was kind of interesting. I said
I,
maybe I
I've
can
heard
do
of it.
some of
I'm
that.
not sure it's going anywhere, Paul. It's
Yeah, and maybe we could do some of that, right? So basically, that's where I ended up in the door at Intel from a
yeah.
very much software-based background. I think my first kind of major role would have been in the rollout of the first ever email servers, across the world, and that'll tell you that will date me quite a little bit when I used to get things like, test email from my friends. Hey, did you get this email? Does this have an attachment? Uh,
I remember those days. I do as well. I think that dates
yeah.
us both a little bit.
Yeah, does the picture of my dog come out clear in the attachment sort of thing?
Well,
So, you
after
know,
half an hour downloading it, usually is the
yeah,
answer to that, if I
I'm
remember.
dating myself back in those days, but that was my career. So I had a technical role, engineering management, stuff like that. But I think my passion was always in more externally facing. Even as an engineering role, I like to meet with customers. I like to tell them about the technology. I like to tell them about the benefits of that and how we did it and stuff like that.
Well, that
And I think
brings
I've
quite
almost
nicely,
come full circle.
I
Yeah.
guessed, into what Intel's plan is for for confidential computing, and what are the key sectors, and who benefits, and who pays for it as well. And these are important questions for any business.
Yeah, I think, I mean, where are we now? I mean, if we step back into the journey that we've been on,
No, yeah, actually, let's go there first.
yeah,
How did confidential computing kind of start? What was the back in the day? Because Intel led this right from the beginning. Where did it start?
yeah, we like to think we let it, right? I mean, I think back to those blockchain days for me, I'm not the visionary here. There are incredibly smart people at Intel who are much smarter than me, right? But when we looked at the blockchain space, we said, hey, this is something that everybody's talking about. I think we coined the term blockchain tourism, right? Because everybody rings up the big companies and said, hey, what are you doing on the blockchain space? And we had incredibly smart people, Dan Middleton, Simon Johnson, these guys that are well known in the industry here. And we looked at different things. So we had our own ledger called Sawtooth. And when we had our own ledger, one of the demands from the market was, well, how could we assert some privacy into this ledger, right? Could we do consensus protocols that were private, like using trusted time or something like that? And that led us to look at this other technology that we had on the client side called Intel SGX, right?
And what do you
And
mean by
in
client? Because that's a
Oh,
very
sorry.
particular Intel word, isn't it?
Yeah, it is a very particular Intel word. Your laptop,
Right.
right? Or a
As
end
opposed
user
to
device
server type
as opposed to
stuff, right?
server.
Right.
Intel is about what we ship to the desktops and what we ship
Yeah.
to the data centers, right? So that in the desktop end of things. So we had this technology that was really built into vPro and other technologies where you could securely store a fingerprint if you wanted to log onto your machine using a fingerprint, etc. And so, the idea was, well, maybe we can use this technology for blockchain where we can execute smart contracts inside of a trusted area where those contracts can't be manipulated or the outcome of it can't be seen, et cetera, et cetera. And that was the sort of start of a privacy layer on the blockchain. Now, that was around 2016, 2017. At around that time and running concurrently to that was this concept of GDPR. You remember that sort of thing, right?
Yeah, a little bit.
So the GDPR preparation had started, et cetera, et cetera. And the cloud providers, and this is where we have to give a lot of credit to Microsoft in particular, Mark Russinovich, Graham Berry and his team. Their view was that, hey, there's a trust problem in the cloud. This is a parallel conversation. And that trust problem in the cloud, how are we going to assert trust back? How do we bring that back? And they were thinking about technologies. We had memory encryption technologies and stuff like that, but that wasn't economic, etc. And then conversations started to happen around, well, could we use this Intel SGX technology? And I'll explain a little bit what that is in a minute. Could we use that as a cloud-based technology? Or could we
Sure.
take a lot of these desktop servers and stick them in the cloud, right?
Yeah.
Just to bring this privacy layer into the cloud. So that's where we kind of started all this. That's how that journey evolved. Now, Intel SGX was a technology that was, as I said, existed, but it was pretty small and it was not easy to work with at that
I
point either.
remember. I remember. I was
Yeah, you
involved
remember it well, right?
back
But
then.
I mean, but it did exactly what it said on the tin,
Yeah, yeah,
right? I
yeah.
mean, that was the point of it. And it was, the best technology around at the time. People also had started to look at things like holomorphic encryption and secure multi-party computation. And although they are fantastic technologies. They have their place in certain areas. They really weren't anything that you could take to the cloud for any type of industrial
Yeah,
processing.
yeah.
Let's go in that sense. So that's how we sort of started the first interactions with the cloud players, and that's where we sat down one day and said, what are we going to call this? Right? AMD got involved, lots of other people got involved, and you know where this ended up, right? So we said, right, let's pick a name. I can still remember all the emails flying back and forth
Yep.
and coming in to work one day because it all happened in the US, and somebody said, hey, we're calling it confidential computing. I think that was 2018, and then that spawned the confidential computing consortium. And at that point, we had a base layer to build upon.
Yep. Excellent. Well, that gives us a starting point. Let's kind of move on to sort of now, where I believe it's not just SGX. We have another technology, right, which is TDX. I'll let you talk a bit about that. So maybe just tell us briefly about that and maybe how it's different. But let's move on to sort of, again, who's going to be using this and how's it used. I don't want to bore people who, well, I'm not bored by it, but not everyone is as interested in the nuts and bolts as you and I. Paul. So let's tell me a bit about TDX, and then let's talk about how it's going to be used, or how it's being
Yeah.
used.
So the journey, I mean, when we built SGX, we had small enclaves, and enclaves are what we call trusted execution environments. They're, where you can run your secret operations inside of this encrypted memory called a trusted execution environment. And they were, I guess, we pioneered enclave-based security at that point, right? The early use cases for SGX, especially in places like Azure, were finance, healthcare, and as you said, blockchain, which I guess we now call Web3. And they were small use cases, people doing maybe anti-fraud analysis inside of SGX. And there's still a lot of companies doing that type of operation in Azure in particular with SGX. But, the SGX built developer friction, there was complexity, the ecosystem, wasn't maturing quick enough to make this an easy technology to adopt.
Yeah.
And the golden word at the time was, how do we get to lift and shift? How do we take a workload and simply plop it into an
An
enclave and everything
existing
works?
workload that we've kind of worked up and we've created the system and with the
Exactly. Right.
minimum changes, right? Okay.
Exactly. Right. So you may have a cloud service or whatever, and you just want to plop it into, something like that. SGX can't do that, right? SGX is, probably the best technology to, ratchet down something security when you build it from scratch,
Sure.
etc. Right. So our plans are always to get into the confidential VM space. So how do we build this confidential VM? And we had pioneered Intel TDX. We're at Xeon 6 now, and we brought TDX to market on Xeon 4, which we call Sapphire Rapids here. And basically, in really simple terms, it's a confidential VM, right? And in theory, you should be able to spin your confidential VM up in the cloud and utilize your software inside of that. And the cloud
And it's
provider can use
isolated from everything around it, including the
it's
cloud
isolated from everything else.
provider, any
Yeah,
any malicious
yeah.
workloads, or even a malicious kernel or malicious IT or sysadmin type person, right?
Exactly right. So the cloud provider, or let's just say the owner of the machine, can either see or influence, what's going on inside of that enclave. So TDX is the confidential computing technology of choice, I think, for us. Right, SGX has its own place in the security world. But confidential computing is really now all about confidential VMs. And we should say that AMD SCV is obviously also in the market there. They were out a couple of years before us. And that's also a big force in the confidential VM market across the hyperscalers at the moment as well. So that's where we are at the moment. TDX is on all Xeon servers. The plan
So
is
it's pretty
well,
much everywhere. Basically, you
pretty
just
much
people don't necessarily know about it and don't know what to do with it if they do. So that's one of the things I guess that you're working hard to try
well,
and
that's what
change.
we're yeah. And so, we can look at TDX at the moment. We can think to ourselves, what's the digital infrastructure going to look like in 3 or 4 years' time, right? Mark Russinovich is on publicly said that Azure will be confidential VM on at some point in the future, and you're going to have to turn off
So it
confidential
becomes a
computing.
default.
It
It becomes
becomes the
a why wouldn't you use it rather than why would you use it? I guess.
it becomes the default, yeah. And so that is a great place to be. I mean, when people have asked in the past, what's the goal for confidential computing here at Intel? Well, it's really ubiquity and commoditization, right? I mean, it's that's what we want it to be, right? It's a differentiating technology here, and as we evolve workloads, we can't stay still and say confidential TDX is confidential, therefore our job is done. It's constant. Workloads are constantly evolving. Regulations are constantly evolving. Clouds want to get faster, etc. So there's more work to be done on top of that commoditization and sort of ubiquity that we're striving towards as well. So it's really at the moment, though, it's a hyperscale dominated place at the moment, and I think we're seeing, Google, Microsoft, Ali, ByteDance, all the big players, AWS, with confidential computing offerings. Now it's almost like, I was on a panel recently, and we call the panel the quiet revolution. People are turning on confidential VMs everywhere, but nobody's really talking about it.
So I know that Super Protocol and Intel have been working together quite a while. I'd love to know a bit about how long you've been working and what that has looked like. And B, I know that they are one of the things they're passionate about is trying to make things easy for people to do stuff. Tell me a bit about those things.
Yeah, yeah. So I think we went back. We talked earlier on about difficulties with SGX for developers, et cetera, to build sort of confidential computing solutions. I think we first met the team at Super Protocol back in those days, where they built some pretty smart stuff with SGX. We helped them a little bit, but they built some very nice stuff around retail as well. Since then, Super Protocol started knocking on our door very early. In fact, maybe before we'd even thought about how we're going to develop the bounce buffer solution that we have now with NVIDIA GPUs, with a desire to use end-to-end GPUs. And so that was kind of interesting. We actually at one point stepped back and said, how are they going to do it? But they did it, right? And
Nice.
so now with their Neo cloud, we could have actually referred to Nebius AI cloud earlier on, where Super Protocol are building. Some of the use cases that are developing out of that are very, very interesting use cases. And, for things like the expansion of electronic healthcare capabilities, that's all things that need to get done. And that's all things that are very interesting. We can, start to think about how we could have, AI assisted diagnostics, which is something I think everybody would like to do,
And
to have
personalized
something
as well,
and
specifically
personalize it, which is
where
the
the
whole
data is
point, right?
even more important to
Correct,
protect,
right?
right? Yeah,
Right.
yeah.
But to personalize it, what do you need, right? You need the actual data of the people, the stuff that you're not going to pin up on a post on the main street of your town, right?
Please.
You need
Yeah,
that
yeah.
secret stuff. And so that end-to-end AI assisted diagnostics built on, the privacy that you have handed over in trust to the clinic is really what you want. And I think that's an exciting use case. And I think expansion in that area is really going to be a big thing over the next 5 or 6 years.
And with the verifiability that we get from attestation, we can prove to the regulators, we can prove to the users, we can prove to the clinicians that what is happening has been done properly and is appropriately safeguarded and made
Yeah.
secure. No,
Yeah.
that's
And
great.
and and for the end user like you or me, you're abstracting everything. You have that control over your data. You're the one
Yeah.
that presses the button on an app or whatever, and that's it. And that's exactly what we want to be.
I go and speak to people about it, and they're surprised that you can get it in pretty much any cloud you can think of, right? Let alone just if you get a high end server, you can run it on your own in house because there are absolutely use cases for running it in house as well. I'm aware, although as you say, it's hyperscaler, dominated. Which I mean, speaking of things which dominate in the market at the moment, we're speaking in mid to end 2025, and AI is still here with us. And as far as I'm aware, we don't have robotic overlords, but AI is with us. Do you want to talk maybe a bit about Intel's view of AI and confidential computing and the overlap? I guess you got lots to say, but yeah, give us a little intro to that.
Yeah, I mean, like AI I don't know about you, but I mean, AI took me a little by surprise,
Oh,
right? I
okay.
think I
I can be
broadsided a
honest
little
about
bit.
that. Yeah.
Well, let's just say Gen AI at least, anyway, right? And I mean, I think the good thing from our perspective is that, hey, this Gen AI stuff, we've got to do something about this, right? But ultimately, all of this Gen AI stuff, and we can throw out RAG or whatever it is, it all needed access to data, right? And this is what confidential computing has effectively been doing, is like protecting secrets, whether those secrets are keys or data or whatever. It's
Yeah.
in that area, right? So all of a sudden, you had these new untrusted models that needed to open up your
Yeah.
data, etc. But then you had the flip side of it. People go, "Well, how am I going to protect my model? That my entire valuation is based on this model." And you somebody over there going, "Well, my data, my model, my data. So we have a solution for you, right?" So basically, AI has become the dominant workload for confidential computing at
And
the
how
moment.
quickly did that happen? Was
Like,
that a
honestly,
fast,
Mike,
almost
honestly,
overnight?
it felt like weeks, just in a couple of weeks, it
Really?
felt like it.
Wow.
You know, Intel has a very strong relationship with Nvidia at the moment because we're
Yeah.
working together. So the big challenge is, so how do we, true AI world, how do we secure end-to-end CPU, GPU, right? So
Yeah.
that's a big challenge for us. So, we're working on a technology called TDX Connect. TDX Connect is a way of bridging between a Xeon head node and a NVIDIA GPU. And so we
Because
can,
that's the thing. Nvidia has confidential computing in their chips as well, right? And I'm going to go. I'm going to launch it. I correct me if I'm wrong, but I think uses TDISP, right? Which is the just to drop a little techie thing to make that connection in a secure way that everyone could be happy about, right?
yeah, yeah, yeah. So, I mean, so TIO is what, is we're going to.
TIO. So that's Trusted Execution Environment Input Output. Is that have I got
Correct.
it?
Correct. It's
That's
it's a
okay. Good.
mechanism.
Okay.
Yeah, it's a mechanism or a protocol stack that
Yeah.
allows devices like, and this is really important as well. It allows devices, heterogeneous devices, to be securely assigned to a trusted domain, right? While maintaining confidentiality, integrity. I pause there on heterogeneous devices because we're building TIO with TDX Connect architecture.
Mm.
We're building that for IPUs, for NICs,
Yeah, so
for
it's not just everyone said. I remember when we were first coming up with the definition of trusted execution environments and confidential computing. We used CPU, and quite quickly we realized that we need to change it to CPU or GPU or other. So we try and move away from that because, as you say, it's the heterogeneity, right? It's any part of your system may be doing computation or transferring or otherwise acting on data or models or applications which have requirements around confidentiality, isolation, integrity, and therefore you need to be able to plumb it all together. And that's what you're talking about here, right, Paul?
Yeah, it's the entire end-to-end part of it, right? It's pointless having a confidential VM to do a part of your AI, whatever you're doing, and then switch it in plain text off to a GPU, right? So your risk is right at that point, right? So now what we're doing is that we're building that end-to-end. So the encryption is end-to-end, and the devices kind of test to each other.
I'm
And
so
that.
glad you used that word. I was about to say there's a word we've not mentioned
I
so
was
far in
thinking,
this
how can I
conversation.
sneak attestation into this
Yeah, no,
conversation?
attestation. Because we when we talk about security, everyone says, "Oh yeah, things need to be secure. They need to be isolated. They need confidential," and they're quite right, of course. But it's all very well if I say to you, this thing is confidential. The first thing you're going to say to me is, well, prove it, right? And that's what attestation's about. So do you want to talk a little bit about that and why it's important in the AI case, for instance, how you can use it?
Yeah, I mean, so attestation is, sometimes we call it the superpower of confidential computing. And it's something that has been underplayed, I think, over the last couple of years, but is now rising to the
Yeah,
top, right? It's really becoming something
I agree.
important. And there's a lot of great attestation projects going on out there. But the core idea is, attestation is how a system proves that a workload is running inside a genuine, untampered, trusted domain, in this case, a hardware-based isolated environment created by Intel TDX, for example. So in simple terms, it's the trust handshake between the TD, the trust domain, and whatever external service wants to rely on its integrity. And that external service could be a cloud orchestrator or some enterprise verifier or some partner application. But it basically answers three questions. Where am I running? On an Intel TDX enabled hardware.
Yep.
Good. Am I secure? Is my firmware VMM TDX module all verified? Good. And can I prove it? Yes, here's a cryptographically signed report to prove it. And you get all that, and then you go, this is a good environment for me to do my secret work on, right? And so then, without all those cryptographic proofs, why would you trust the owner of
Yeah.
that machine
Yeah.
that it's all up to work? So from that perspective, it's very important. But why it matters is back to what you said. Without attestation, you're just assuming your workload is running securely. With attestation, you can prove it even in a sort of shared or untrusted cloud. And in the world that we mentioned GDPR a little bit earlier on, in the world that we have right now with compliance and all these different things coming down the line, we said GDPR, but you've got things like NIS2, DORA, the financial services regulation talks
Yeah.
about confidential computing, being something that should be used. So that proof you get from attestation, enables you to use regulated workloads and prove that you use confidential computing to do it, right? And it becomes part of maybe a valuable part, maybe a valuable tool in your compliance workloads, et cetera, et cetera. So that's why that's important. Now, if we go back to our AI example, the Intel CPU can't just assume that the NVIDIA GPU is trusted. It has to prove it. So it goes through an attestation protocol with the
So
NVIDIA
the
GPU
GPU and the
and backport
CPU
it.
attest to each other to prove
Correct.
that one can trust the other, and that the CPU can pass the data to the GPU to be processed, and
Yeah.
no one's going to be able to mess with it as that happens. Right? Okay.
Yeah. So you get my cert. I like you. Here's the data. I'm
Certificate.
waiting
Yeah.
for it to come back. Yeah. So from that perspective, so I think that's really critical. And I mean, we have our own Intel Trust Authority attestation service. We also, most importantly, ship libraries to do attestation to give
So
you
people
the
can build
capability
their own, do their own.
build
Yeah.
their own.
Yeah.
Yeah.
Sure.
But we like things like Trustee, the Red Hat project and stuff like that. And a lot of clouds that are building confidential computing infrastructures, like the hyperscalers, will build an attestation service as well. But even internal services, you can think of government deployments and stuff like that. Even internally, that attestation stuff is pretty critical as well.
And I know that data privacy and security are a real concern for people when they're looking at AI, right? Because it's not just the data, but it's the models that come out. If I'm a big bank and I've got and I'm using AI to help me decide whether to make a large purchase of another of a company or something, or to advise if someone else could look at that or change it, then that's my business crown jewels, right? That's the thing I care about the most. So protecting that and being able to prove to your auditor, to your board, your regulator, whoever it is, that things have been protected all the way through. You get a kind of a provenance story all the way through. And so, is that part of how you're talking to these financial institutions, and who else as well? You mentioned financial, but who else are the people who are caring about this?
Yeah, I think it just yeah. I mean, we could talk about attestation all day. You can attest to the environment, but really, a lot of the work's going on around how do you attest to a certain workload, at a
Sure.
certain point in time and stuff like that, because workloads sometimes take time, etc. So attestation, though, for anybody listening to this and anybody considering deploying confidential computing technologies, the concept of attestation is very important. It may not be the first thing you want to do because there's a lot to do to build a confidential infrastructure, but it's certainly where you want to end up, right? It's the closing chapter in the book, I think, from that perspective. Back to your question on, where is confidential computing prevalent at the moment? Had we had this conversation maybe 2 years ago, we would have went and said, hey, financial services, these companies really need some help to adopt cloud technologies. They
Yep.
need some help to collaborate. And so that's, a very key vertical, healthcare as well. And the difference, or sorry, not the difference, but what they have in common is that they hold on to very personal data, right? And, that allows them to do potential collaboration in private. But I'd say over the last 2 years to 18 months, there isn't an industry that isn't utilizing confidential computing at this point in time. I mean, we
Yep.
we talked to a very big major retailer a couple of weeks ago and really surprised us, A, how much they're reliant on confidential computing, and B, how much they're actually using from a kind of VM perspective, right? And, the reason they have to do that is that they have stores all over the world. People come into their stores all over the world.
Yeah.
Those people buy stuff, and the heavy duty analytics workloads that is behind all of that are what we call the high impact mature workloads. Transaction processing and analytics is all done in confidential VMs in the cloud, right? Because it's multi-country and stuff like that. Out of that, they're building their entire analytics strategy, and that strategy then helps them to define what they're ordering, when they're ordering it, et cetera, et cetera. So kind of very interesting. That's a retail space, right, where you might buy, a shirt or something like that, right? And they
Yeah.
moved very fast, right? So they moved very, very fast to do this. And then, lots of other really interesting space with social media companies, advertising, and, we're moving into this, cookie deprecation.
Yeah, and the whole GDPR and ad tech, you forget how big ad tech is and how much they became worried by GDPR, right? Because they need to be able to prove they're not misusing this information they have. And confidential computing is exactly one way of doing it. I've spoken to a very, very large, advertising platform for whom it's an absolute be all and end all that they have to be able to do this.
Yeah, I mean, it's essential, right? And I mean, but it's also making them a hell of a lot more efficient. I think the biggest advertising companies in the world are really now the social media companies, right? And I think they are the guys that are moving towards efficient privacy solutions. And the most efficient privacy solution right now is a confidential VM on a hyperscaler. That's really the most efficient one. So they're using that as their cryptographic intermediary in this space, right?
So
And you look at things like, WhatsApp are very open about their use of confidential VMs. Signal is very open about its use of Intel-based technologies,
yeah.
confidential VMs as well, to protect stuff like that. And I think it's encouraging to see that companies like that have had privacy problems, are looking to address it and address it publicly. So I think kudos to them from that perspective.
So you've mentioned hyperscalers on a couple of occasions and these big CSPs, right? But I learned a new word just very recently, which I'm hoping you can tell me a bit about, which is neo clouds, which is presumably nothing to do with the matrix. Can you tell me about neo clouds?
Hmm. Thinking. I think the way I look at Neo Cloud, and the reason I was thinking because I've seen it come down and up, and I'll try to explain that in a second. I guess Neo Cloud for me is an emerging concept in cloud and AI infrastructure, right? So that's the merge of those two, right? For me, it's a sort of class of cloud provider that purpose built for AI and GPU workloads rather than the general purpose computing, right? So that's the way we see it. Now, what's very interesting about that is that a lot of these neo clouds are offering GPU as a service, AI infrastructure optimized environments, specifically for sort of machine learning, deep learning, if it's tasks, et cetera, right? And some traditional clouds that we know are, let's say, traditional service providers like Equinix, for example, are moving into this space as well. But they do a lot around performance prioritization, lower latency, and bits and pieces like that.
Yeah.
The reason I paused earlier on is because I've also seen clouds that were specifically built up to be mining clouds, now moving down into this space as a GPU as a
They
service.
got all these GPUs that are maybe not being utilized as much as they might, and they realize they can
Correct.
make
Or,
more money
or
elsewhere. Okay.
I don't know. I think I read somewhere that mining will cap out in 2027. I think they're preparing for that type of thing. But
Okay.
I'll give an example. So we did an interesting paper there recently with Supermicro. And again, we've talked a lot about hyperscalers, confidential computing and cloud only play. Well, I think the hyperscalers are leading the way. Now the OEMs are getting interested because we have sovereign clouds and confidential computing is coming into the enterprise. But the neo cloud, with this Supermicro paper, there's a neo cloud called GMI. They're publishing this paper, and to be honest with you, we'd never heard of them, right? But these are new
Really?
companies with new
Yeah.
money that are buying lots of kit, and they realize in their neo cloud to provide GPU as a service for proper workloads, they need to do it confidential. So they are now building on Supermicro with Nvidia a full end-to-end encrypted GPU service, inferencing
Yeah.
service, etc., etc.
Yeah.
But we also can look at great companies like Edgeless Systems, right? What Edgeless are doing with private mode AI, their private inferencing service. And this is these services are really valuable for governments, departments that generally would move a little slower than enterprises where they can take workloads. They can do vibe coding, for example, in sort of,
You are down with the
projects.
kids. Vibe coding, Paul. Very impressive.
Yeah, I learned that. The other day, and actually, I did a session with our team in Poland, and I called it Vibe as well, and all the
I
kids were
bet
very
they loved it.
impressed. All very impressed with me. Yeah, so I'll credit Jesse Schrader at Intel for teaching me what vibe coding
Good
is.
old Jesse.
But I think that's what neo clouds are good, and I think we're now seeing a lot of these neo clouds because they can move a hell of a lot faster than the hyperscalers. The
Sure.
hyperscalers
And
face
because they're
bottlenecks.
specialized, yeah, absolutely.
They're generally
Excellent.
cheaper. You can get bare metal if you want as well from that perspective. Yeah.
Great. So, moving on to something slightly different, we talked about some of threats generally and how people need to protect that. I want to talk maybe a little bit about how these threats have grown from just being targeted at single companies in a single location to looking at sort of national level or cross national threats as well. Sort of national level data security. Just the volume of breaches and how companies have a requirements from national regulators to do the right thing, and international requirements as well. So how do we think about that and confidential computing? And also, I'm hearing more and more about data and even compute sovereignty. Are those things that you're hearing about, and where do you put those?
Yeah, I mean, sovereignty is maybe covers all of the things you said there, right? I think the geopolitical context, I guess, around where we are at the moment. I mean, I think in some of the conversations we've had, nations, maybe especially here in Europe, are increasingly treating data and AI models as critical infrastructure, right?
Yeah.
On a par with energy and defense, right?
Wow.
It's
Okay.
kind of
It's that important.
what's yeah, that's kind of what we see, right? And state actors are targeting intellectual property, citizen data, and model weights, right, through all
Mm.
sorts of espionage or supply chain compromise, which is another big area for sovereignty to address, or generally a lot of things around insider access, right? Or that still is the big door. So, I mean, I think here in Europe, and I'm not an expert in this area, but in Europe, there's a lot of sovereign data strategies that we're seeing, EUCS, the CRA, NIS2, DORA, we mentioned earlier.
Yeah.
Gaia X was another attempt to do this. The EU AI Act has now come in as well, right? And all of these are providing a framework for how to do things, right? They're not telling you how to do things, right? Sovereignty today means not just where data resides, but how it's protected during computation, right? So for example, you can't be sovereign if your workloads are exposed while you run, right? So I think things like state-sponsored cyber intrusion, data exfiltration, model theft, all those type of things are getting covered under this national threats sovereignty play. But in all of these, confidential computing is an important tool in the toolbox.
Yeah. Yeah.
It's not, for example, going to say, right, use confidential computing and your state-sponsored cyber intrusion will never happen. But what it means is that if somebody does get in, well, then TDX enclaves and attestation will still create a hardware forced isolation if everything is compromised, as you said earlier on, right?
So there is no perfect security, right? But what confidential computing allows you to do is say that firstly, it's a great defense in depth. Your system's going to need lots of different types of security at different points in the system, but also it's going to be not. It's not going to be the weakest link anymore. Whereas data in memory was kind of easy to get to via a whole different sets of ways. Suddenly, this is not the weakest link. And so you can build a defense in depth, a story around your system, choose the appropriate security measures and protocols and technologies, hardware, software, for what you're trying to build. And so that, I think, is where we're seeing the data sovereignty people realizing that this is a great tool, or a toolbox, shall we say, of things that they can use to do that and have that assurance. And because that's the other thing I want to talk about, right, is verifiability. We've kind of talked about attestation for, being sure that what you're running is running in a safe place. But you can do more than with that, right? You can say,
Yeah.
I can be sure that what is running and the data that's in it is what I think it is, right? And
Yeah, I think. But I think just to back to your point on the
Mm.
sovereignty piece, I mean, and the regulations and all those type of things, all the regulations talk about state of the art, right? What is state of the art?
Yep.
Encryption is state of the art, right? There isn't enough use of encryption, right? And where there's encryption, this confidence computing stuff can really help you, right? And if you have threats, people get in your network and they steal encrypted data. That's bad, but it's not that bad, right? From that perspective, and I think that's where we're seeing confidential computing rise as a tool in the encryption toolbox in all of these sort of areas. So that's really important. And then, as we talked about attestation with your cryptographic proofs, so the combination of those two, again, it goes back to why would you not use it, right? And that problem is awareness, right? And we know that through the work of the Confidential Computing Consortium, we know that we still, with confidential computing, have an awareness problem outside of the hyperscalers and in the enterprise and in the governments and stuff like that. And that, I think, is a big challenge for anybody involved in confidential computing at the moment, including the cells at Intel, Confidential Computing
Mm.
Consortium, AMD, whatever, is
Yep.
to make more awareness of confidential computing as a privacy enhancing technology. For me, we said earlier on about this AI stuff just happened, right? And all of a sudden, we all use ChatGPT or whatever your flavored LLM is. And they've become like personal assistants, right?
Yep.
But imagine I could get physiotherapy from ChatGPT, right? So, how can we build an AI clinic, right? So what I want to do, or what I would like to go, is go to a clinic and have it enable an AI assisted, sorry, diagnostics and treatment support. In order to do that, I mean, that would be great for me, right?
Yep.
Rather than have to pitch up to my physio for 11
Yep.
sessions or whatever, I could do it whenever I wanted. But that obviously, that treatment, that full support is going to need full privacy, et cetera, et cetera. So I think, that's a really interesting use of confidential computing and sort of a Gen AI. And as my own daughters, I can see, them getting hooked on Gen AI and stuff like that. I can see them being people who would really adopt something like that. So this whole end-to-end AI assisted diagnostics, full on privacy, I think that's really kind of cool. But right now, I think Super Protocol pretty advanced in what I would call confidential AI. We talked earlier on about how we connect GPUs to CPUs and build that
Yep.
end-to-end trust. I think Super Protocol are probably, I can't make the claim that they're the first, but they're definitely in that area of being the first and pioneers in this area.
So there's a question there, isn't there? It's one we've been asked before, actually, about how do we, as an industry, if you will, make it easier for people who aren't the techies. I mean, even if both of us have moved away from our peak techdom, as it were, but we both come from that sort of background. But there's a whole bunch of healthcare professionals, for instance, or teachers who really don't. How do we find those people who are going to be using Chat GTP or Pixel or what, as you say, whatever the LLM of the future is, but don't want to have to know how to turn on the TE and the attestation and all this low level stuff and sort out the TDIS. What do we need to do as professionals and as an industry to make that happen?
Yeah, but you're right. I mean, I think, if we go back to the examples of SGX, the biggest barrier to adoption is usability, right? And then I also said commoditization and ubiquity, right?
Yeah.
So it's just there and it's just turned on and it's just used. But that's oversimplistic, right? The way that we build everything is that, Intel is an infrastructure company. We are building the plumbing for people to build services on top of that. We're working
Nice.
very with obviously the OSVs, Red Hat, Canonical, SUSE, to build the orchestration layers on top of that,
So it's
to
operating system vendors, OSVs, right?
vendors.
Yeah.
Yeah, operating system vendors like Red Hat, SUSE, and Canonical, and they will build, the layers above the hardware to abstract, the difficulties away from that, right? But the layer above that is, there's opportunity to build good software that simply uses the underlying capabilities of confidential computing to abstract that away from, clinicians or I don't know, captains of ships or whatever, so that they use
Nice. Yeah.
a trusted framework underneath, right? And so that's ultimately the dream, that the people who are clicking things in a clinic or whatever are clicking in a way. And there's a good example there's a great example in Germany, right? in Germany, they wanted to build a digital health infrastructure. German citizens,
Yeah.
complained it took too long to build this, but now it's in there, right? So basically, in Germany, if you go to a doctor and you get a prescription, that prescription is redeemed now through an app that's stored in the data center, and in every single one of these flows, it goes through confidential computing. So it's completely digital and secure from the clinic back to where it's redeemed in a chemist or a pharmacy, whatever you want to call it, right? And the same then for electronic healthcare records, right? So your health insurance records, again, all digital. They can be retrieved by giving permission to a hospital to pull your details down, etc. And the rate of prescriptions now in Germany, there is over 2 million a day from a digital
And it's
perspective,
all
right?
going through a confidential computing
It's all based on Intel
infrastructure.
SGX. It's all based
Wow.
on great credit to the team at Gematik in Germany for building this out and having it so secure end to end. So it is doable, but the point of telling that story is that the person who's getting the prescription has no idea what confidential computing is, right? The doctor who's writing the prescription, they haven't got a clue what confidential computing is. And the people who are administering, the healthcare claims, no idea what confidential computing is, right? It's down there, it's the new digital infrastructure, and it's completely abstracted from the people who need to use it. That's
Yeah,
where
no,
we need.
that's great, and I'd be really interested to get Gammatic actually on this podcast at some point. There are some interesting folks. I know them as well. Open source, really important force in the world these days. How does it play into this space? Is it important? Is it unimportant? Tell me. What are your thoughts?
Yeah,
And
for me,
what
so
does
for me,
Intel
yeah.
do there?
Yeah, so for me, open source is critical, and I think Intel is very invested in open source, as everybody knows. Why is open source critical in this space? Because integrity is the key to everything around confidential computing and the things we're doing. We talked about attestation being a superpower, right? You want to see the source of the code that's doing the things that you want it to do that gives you that assurance. And if we use the Gematic example again, that entire stack that they built is on GitHub. People can go see the code, etc. So once they see the code, they can trust the code and they understand, what's going on inside of there. Here in Europe, we talked about sovereignty. Deutsche Telekom's open sovereign cloud, for example, is a sovereign cloud built entirely on open source. And we'll see another big player later in Europe announce a big open source cloud as well. So open source brings integrity, and integrity is a really important word in this whole area around data processing and confidential computing, confidentiality. So that's where open source is absolutely critical. But if we're going to build a layer that we want to have others build trust on top of that, we've got to give them the tools to do that,
Yeah.
right?
So if the foundation isn't, you can't trust the foundation, then
It
you can
has
be
to be
building on
open.
anything.
It has to
Yeah.
be open. And like, that's why we invest so heavily in our data center attestation protocol tools that we put out there as open source as well, to allow people to build that integrity from that layer up, right? Which becomes the pillars of
Yeah.
what people do above that, right? So open source is critical, and it's something that we'll continue to invest in. And I think, I would encourage others to look at that as well. There are others building interesting projects in open source. There are others building in closed source, and I think that's okay depending on where in the stack that
Yeah.
you sit. But if you're down at the layer like ourselves and AMD and others, NVIDIA, open source is really critical.
Excellent. No, I'm a big fan of open source, as you are very aware. What have we missed? What are they? What are the things that you would like to be talking about that I failed to talk about? What's important that in your world? What's coming up? What's, I don't know. Tell me.
So for me, the evolution of AI hasn't finished, right? And I think what's very interesting for guys like us that have been in the space is where do we go next? What
Mm.
roles do we play with our technology, right? So we've talked about how we can make the cloud secure. We've talked now about, how we show abstraction of the technology for end users like clinicians, et cetera, et cetera. But we're now moving into a world of agentic AI, right? Where agentic AI is going to be, again, if I go back to my daughters, right? Maybe in 20 years' time, they'll have personal assistants that'll be making decisions for them, right?
I I I
Agentic
I
AI.
I worry it's going to be 20 weeks or 20 months rather than 20 years, Paul. But yeah,
Yeah,
okay.
well, I'm trying to make it easy for people not to panic, right? But ultimately, these agents will make decisions, and some of those decisions may be critical decisions, right? They may write pieces of code based on data that they own by you, right? So, the challenge is, we've talked about end-to-end confidential AI. We're going to solve this puzzle. We've a great plan to do it. But how do we solve the puzzle of making all the agents confidential? How do we make sure that these agents aren't the next massive big privacy leak, right? So this is the next thing to stay awake worrying at night. There's some of the smartest guys at Intel and
I've
they're
got
in the
lots of
industry.
things to worry about at night,
Yeah,
but
yeah.
they need more.
But I
But
mean,
thank you.
yeah. So I mean, but the rise of small language models alongside agentic AI is an area that I think needs to be solved. And I think confidential computing, again, can be a massive component in building this trust layer for, I don't want to say
Yeah.
trust layer for the internet, but trust layer for the agentic world, right? And I think that's the next challenge. And if we think about, are there opportunities out there for new companies to take this technology and build that type of framework? Great, right? And alongside that, then, you mentioned it earlier on, we didn't get into it. What is verifiable AI, right? How do you know that, this model is done what it's supposed to do and it's done it right? How do we understand where the provenance of data, what's the daisy chain for data that's come from the edge to the cloud, et cetera, et cetera? How do we attest to all that, right? So there's a whole trust problem to be solved that I think is the next galaxy that we need to sail our ship towards. And that's the piece that is very interesting.
Paul, we've known each other for quite a while, but I worry about the powers
Me?
of AI. Yeah, well, that's someone I think to, is you, and this is my concern. Honestly, that given the layers of deep fake capabilities going on, I'm not entirely sure that you are necessarily a human and not some AI thing. So what I'm going to do is going to set you a little task, which is to explain something to me in such a way that I believe that you're a human, not an AI, because that'll give me some happiness. Okay, so let's explain to me whether it'll hurt if I drop a brick on my foot.
Explain to you whether it'll hurt if I drop a brick on my foot. I'm pretty sure it's going to hurt. It depends on the size of the brick, Mike.
So I think you've actually answered my question by laughing, but the thought that you laughed at my dropping a brick on my foot was rather upsetting, I have to say, Paul. But why do you think it's going to hurt if I drop a brick on my foot?
Because every time I've dropped a brick on my foot, it's damn hurt.
Okay, that'll do. I think you're probably human, Paul. I'll take that one as a gauge.
I'm not falling into one of your incredibly intelligent
No,
answers.
this is far from incredibly intelligent. This is just a funny thing, just to find out whether people are hopefully able to react in a way which is kind of human. I
Yeah,
think
well,
so.
as I told you earlier on, I ran through the entire Schiphol airport last night from the furthest B gate to the furthest D gate, and
Oh,
by the time I got there, I felt very human.
yeah,
And the guy
and they always
beside me
make
knew
sure
what
it's the furthest gates as well. I don't know how they
you
do
know,
that. Yeah.
yeah, well,
So,
we had to go through Schengen and all that sort of stuff. So yeah,
uh,
so I am feeling very human today.
what about you? What questions do you have for other people who we may have on this podcast in the future? Anything you'd like to sort of pass on as a question or as a request?
Specifically related to confidential computing around.
Verifiable, all of the things that you think we need to be doing in
Yeah,
the industry,
I,
really.
I think I mentioned there that we still have a lot of work to do in how we're going to build trust and how we're going to build provenance. So for the next person that comes on, I would say, what is the plan to deliver data provenance that we can all trust that the data sources are where they came from? Thinking about data source A meets data source B informs data source X, and that meets Y, and that forms B1 and stuff like that. How do we get to that point? And so we allow these agents to at least work on data that we know is the right data.
So, Paul, this has been great. Thank you very much indeed. Lots of fun chatting as always.